This is going to be the last video for max and mins. This is going to be example 3 on the review sheet. We're given a function f of x is equal to x minus 2 cosine x, and we're given the interval from 0 to pi. So like before, just start out with taking the derivative of our f of x. So that's going to be the derivative of x minus 2 cosine x, the derivative of that. Because whenever you have a constant in front of some function or whatever, you keep the constant and you take the derivative of the function. And that's just one of the rules we have for derivatives. So our f prime of x is going to be equal to 1 minus 2, and the derivative of cosine is negative sine x. So then whenever you clean that up a little bit, you have 1 plus 2 sine x, because our negatives become a positive. Alrighty, so the next step is we need to set that equal to 0. So we're going to have negative 1 is equal to 2 sine x. So sine x is going to equal negative 1/2. Okay, so here's what we had just found. Our derivative was 1 plus 2 sine x, and when we set that equal to 0, we came up with sine x is equal to negative 1/2, and our interval is from 0 to pi. So now we need to find out what values actually give us negative 1/2 for sine of x. Okay, if you know anything about the unit circle, the sine of pi over 6 is equal to 1/2. Okay, so what does that tell us? Well, sine of 0 is equal to 0, and the sine of pi is equal to 0. Okay, so how do we know that? Whenever we have our unit circle, everything changes up a little bit. This is like 0 and 2 pi, and over here we have pi. Basically, sine is the y value, so whenever you're actually at 0 or at pi, you're right on what would be the x-axis, so your y value is 0, so that's why the sine of 0 and pi are both equal to 0. Well, sine of pi over 6 comes out roughly here, and once you do the trig and everything else for it using the equation of a unit circle, that comes out to 1/2. And from trig, you know that since pi over 6 is 1/2, and that pi right over here, you're at 0. So if you go pi over 6 below pi, basically you're adding pi over 6 to pi, you're going to have 7 pi over 6. And since you're in quadrant 3, sine is negative, and it is also negative in quadrant 4. So likewise, since we have 2 pi, which is the same as 12 pi over 6, if we take away a pi over 6 chunk, we would be sitting at 11 pi over 6, which still gives us the 1/2, but because we're in quadrant 4, that's a negative. So our two values that give us a negative 1/2 for sine of x are 7 pi over 6 and 11 pi over 6. But as you can tell right up here in our given interval, these values do not fall within it, so we can reject those as bad. And like the last problem, we're just going to be plugging our endpoints right here of our interval into our original equation and solving that to find out what our max and mins are. Okay, so take everything that we know, which is our interval and our original function, and start plugging in everything that we have within that interval as far as critical values, which were the 7 pi over 6 and 11 pi over 6. Those two critical values were outside of our interval, so we don't use those. So we're just going to use 0 and pi. So whenever we plug that in, our f of 0 is going to be equal to 0 minus 2 cosine of 0, and the cosine of 0 is actually just 1. So we're going to have 0 minus 2 times 1, which is going to give us a negative 2. And when we plug pi into our original, we're going to have pi minus 2 cosine of pi, and the cosine of pi is negative 1. So we're going to have pi minus 2 times negative 1, which is going to give us pi minus, we have two minus signs, so that becomes a plus right there. So we're going to have pi plus 2. So that one will go here. And as you can easily see, negative 2 is going to be our min, and 2 plus pi is going to be our max. So the max and min for x minus 2 cosine x over the interval of 0 to pi is going to happen whenever x is 0 and whenever x is pi, for the min and max respectively. Alright, thank you very much, and we'll move on to the next subject.